The definition of the content of volatile components is one of the most important steps towards quality control and safety of alcoholic products. This video was created to facilitate understanding of the principle of the method ethanol as internal standard, which can be used to achieve this goal. Here you can see the basic documents which regulate volatile compounds determination. You see that all these papers consist in gas chromatography method, as it was shown earlier. Let's look at the picture which demonstrates the scheme of both traditional and novel methods of volatile compounds determination. Chromatogram peaks of internal standard compounds marked with color. Traditional method means the artificial addition of internal standard. Also, it is necessary to measure the density of sample to determine its strength. As far as you can see, these two operations absent in novel method ethanol as internal standard. There are two reasons for this. Firstly, ethanol always exists in alcohol drinks, so there is no need to add this internal standard. And secondly, ethanol concentration in milligram per liter of absolute alcohol is a constant value, which is the ethanol density. As I have told above, traditional method includes samples density measuring to calculate strength. But in case of drinks with great compounds contamination, such as brandies or whiskies, it is impossible to determine strength correctly by alcoholometric tables, so there is a risk of great biases. Speaking about theory, it is necessary to mark that novel method includes the same way of RRF calculation as a traditional one. RRF means relative response factor, and this value expresses the sensibility of detector to compound comparing with ethanol. In the picture, you can see the examples of chromatograms of some alcohol drinks. Internal standards are again marked with color. Formulas of concentration determination are also shown, and you see that the right one is simpler than the two left. And what about biases? Novel method is pretty better here too. The absence of extra artificial manipulations logically leads to bias value decreasing. And now it is time to technical part to show the experimental results. The first step was the preparation of a standard solution for the calibration of the chromatograph. The weight method prepares a solution that contains all the designed impurities, including ethanol. Finally, we obtain a standard solution with known concentration of each individual component in the desired units of measure, milligram per liter of absolute alcohol. Determination of RRF was made according to EC 2870-2000 and both to ethanol and pethanol in order to compare the obtained results. On next slides, you should pay most of attention to bias columns. Comparing traditional and novel method, it can be said that the novel method is correct enough and somewhere even better than the old one. So here you see the solution 0.1. On this slide you see solution 0.5. Solution 1, solution 2, solution A, and finally solution with minimal concentration of volatile compounds, solution 1.0 minimal. To date, to access the reliability of the obtained data are being used certified reference materials Series M LGC whiskey congeners. On the right scan are being shown 16 world-famous laboratories participating in the inter-laboratory testing of this reference material. Our laboratory conducted a test on this standard material. Obtained chromatograms are given in linear and logarithmic scales. The tables show the spot of concentration of volatiles and the concentration that was determined using the method. Obviously, that novel method must be taken seriously. There is a photo of internet online calculator AlcoDrinks, which was created to calculate concentration of volatiles using the proposed method. The homepage of it is written below. Summing up, let us summarize the advantages of the proposed method. First of all, it allows to directly determining the concentration of volatile components in units of milligram per liter of absolute alcohol in full compliance with the international governing documents. Secondly, a very valuable feature for the production, no need to add substance externally which saves labor costs. The concentration of the internal standard is always known in advance with zero uncertainty, as it is equal to the density and is a constant table value. An important advantage, of course, is that we can measure the concentration if with a large content. The fact is that in accordance with the European regulation, determination of contents of volatile compounds performed by alcoholometric tables on the basis of measured values of density. However, alcohol-containing products with a high content of volatile components, such as whiskey and brandies, as I have told earlier, make it impossible to correctly identify their strength with an areometer. The proposed method doesn't require the determination of the density of the sample. Here appears another advantage. The method allows to successfully perform the tasks for a sample of small amounts, for example 1–2 milliliters. Thus, the proposed method, ethanol as internal standard, is an innovative approach in the field of quality control and safety of alcoholic products. Implementation of the method requires less labor and time cost compared to the traditional one. Obtaining accurate values by this method indicates their need to recognize the need as a reference one.